Bismillahirrahmanirrahim. Welcome to the Electrical Engineering channel. In this lecture, I am going to discuss the interpolation and its implementation mathematically. So many times data is given at discrete points, and a continuous function f of x can be used to represent n plus 1 data points with f of x passing through n plus 1 data points. Then f of x at any point can be evaluated. This is called interpolation. So for example, in this figure, you can see we have discrete data and it is given at a few points, and we are not having the data at the intermediate points. So for example, this is x equal to 1, this is x equal to 3, but at this point x equal to 2 or x equal to 1.5, we don't have any data point. But if we make a continuous function f of x, and if we derive such a function and if we plot this function, and if this function is passing through all of these data points, then we can estimate the value of this function at any intermediate point. So estimating the data value at any intermediate point is called interpolation. So for example, the value of the data is given at this point, and at this point we don't have any information at this point, but we can do interpolation and we can estimate the value of the function at this intermediate point. Similarly, we are given the data value at this point, so we can do interpolation and estimate the value of the data at this point, similarly at this point. Sometimes we are not given the value of the data beyond this point. Okay, so still we can estimate the value of the data beyond this point, and that will be called as extrapolation. So if x lies outside n plus 1 points, it will be extrapolation. So here we have n plus 1 total points. There are n segments. Okay, so this is one segment, this is second segment, this is the third segment, and we have n plus 1 data points. So this is the data point x naught, this is x1, this is x2, and this is x3. So if we want to estimate the value beyond these n plus 1 points or before this point, then that technique is called as extrapolation. So the first method to do interpolation is called a direct method, and in direct method we will use the conventional polynomial, and that polynomial y is equal to a naught plus a1 x plus a2 x square plus so on up to a n x raised to power n. So any function, so if we have a function of any shape, we can use this polynomial to represent that function, even if that is a cosine function, sine function, any trigonometric, logarithmic, exponential, or any other function. All those functions can be represented by such an infinite polynomial. And when we use such polynomial to do fitting, we have to first calculate these coefficients. These are the unknown coefficients a naught, a1, a2, up to an. So here we have n plus 1 constants a naught up to an, and they can be found out by solving n plus 1 simultaneous equations. So we have to build up n plus 1 equations if we are going to find out n plus 1 unknowns. So let's solve one example to get a deeper insight into the direct method of interpolation. And in this example, we are given the upward velocity of a rocket, and we have to find out the velocity at t is equal to 16 seconds, and we are given the velocity of the rocket at discrete time points. So t is equal to 0, 10, 15, 20, 22.5, 30, and 35. At these points, we are given the velocity of the rocket, and we have to find out the velocity of the rocket at t is equal to 16 seconds by using a direct method of interpolation. So in this direct method, we have to use a first order polynomial, or we have to do first order polynomial approximation. So if we are going to use first order polynomial approximation, then all these higher order terms will be neglected, and we will only be using first two terms a naught plus a1x. So this is the function in which everything is given as a function of time. So time is our independent variable. So v of t is equal to a naught plus a1t, and we have to determine the value at t is equal to 16. So we have to use two values, 15 and 20, because 16 lies between these two time points. So t naught is equal to 15, t1 is equal to 20, vt naught is equal to 362.78, vt1 is equal to 517.35. So we can build up two equations from these 2 points. So v at 15 is equal to this, v at 20 is equal to this. So we have two equations and two unknowns, and we can write these simultaneous equations in the matrix form. So by solving these matrices, we can calculate the values of a naught and a1, and they are given as minus 100.93 and a1 is equal to 30.914. So this is our interpolation function between t is equal to 15 and t is equal to 20. So in this function, we will just put the value of 16 as t, and we will get the velocity. So this is equal to 393.7, which is the interpolated or approximated value. So in the second example, we have to use the same polynomial, but with the second order polynomial approximation. So it's direct method, but with second order polynomial approximation has to be used. So this is our second order polynomial, and here we have three unknowns, a naught, a1, and a2. So we must build three equations, and we must need 3 points. So we are going to determine the velocity at t is equal to 16. So let's choose 10, 15, and 20, these 3 points. And from these 3 points, we can build three equations. So t naught is equal to 10, vt naught is equal to this, t1 is equal to this, and vt1 is equal to this. T2 and vt2 are also given. So from these three equations, uh, we can find out three unknowns. So these three unknowns can be found out by conventional algebraic method, or by matrix method, or Cramer's rule. So there are several methods which can be used. Gaussian elimination method is one another method, from which we can find out the values of these three unknowns. So you can use any of those methods, and these matrices can be solved by scientific calculator, and it won't take too much time. So these are the calculated values of a1, a naught, a1, and a2. So this is our polynomial, which is second order, and in this polynomial we will put t equal to 16, and now the evaluated value is 392.19. So that was the direct method of interpolation. I hope you have enjoyed and understood the concept of direct method of interpolation. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.